Today we're going to look at what IBM Corporation did to save itself hundreds of thousands of dollars a month and then millions of dollars over the course of time just by changing the way it used its water at one of its plants in Burlington, Vermont. Okay, if you don't know what IBM does, it stands for International Business Machines, and it was one of the main computer producers during the 80s, but over time, now what they're mainly known for is their microchips. And these microchips can be used in computers, they can be used in printers, in cell phones, in televisions, all different types of things that they're making these microchips for. And when they make these microchips, they need something that's called ultra pure water. And ultra pure water is a liquid that is so clean it actually isn't safe to drink. Okay, it requires its own separate factory inside the microchip plant. And IBM's water staff measures 80 characteristics all the time in real time, including the temperature, the flow rate, the pH level, the clarity. And IBM Burlington has wired the plant's pumps, tanks, and pipes with 500,000 electronic sensors, each of which gathers about one data point a second. That's a stream of 300,000 data points a minute. Okay, and what a data point is basically a piece of information. So every minute, they're recording 300,000 pieces of information. That's more than our brains can process. Okay, that's like at the bottom of your screen when they do like the little crawls that come across with like the news of the day. That's usually they say that's usually about 52 data points a minute. And for most of us, that would be hard to read all those 52 things going across. Put that into the mind of a seventh grader, you guys are capable of probably reading about 10, maybe, if you're paying attention and not staring off into space. Or now that we're at home on our Chromebooks, looking at, different tabs or listening to music and not paying attention. So they're using all this information to figure out if the water is ultra pure and they can use it. And then they're using that information now to figure out how they can reuse that water. Okay, so what they're doing is taking this water, they're pumping it into their factory, and they were spending so much money on this water that they started to think about, okay, we have to find other ways to save money on this because we need to make this ultra pure water because we have to have it, because if we don't have it, we can't make our microchips. And the water has to be ultra pure to make the microchips, because if it's not, then the microchips are defective. They're not going to work properly. It has to be this way. So what they started to see when they looked at the pipes of all this water coming in, they just kept seeing the dollar signs of all the money that was running in there and how much how much money they were spending on water every day. Okay, and it said the water bill at IBM Burlington, just to get 3.2 million gallons a day, that's how much you're using every day, cost them $100,000 a month. That's just for their water bill. So the water staff turns the plain municipal water, so just from like the tap, into a portfolio of products, depending on whether someone is mixing high-tech chemicals or running air conditioning chillers. IBM's utility plant creates 9 custom varieties of water. Each brand of water costs 4, 5, or 10 times more than the cost of the raw water itself. Okay, so a few years ago, Jeanette Bombardier, site operations manager in Burlington, her staff had a revelation. Water is so important that although it seems far removed from the final product, the computer chips, it could actually be a competitive advantage. And they moved from making chips for IBM products to making chips for consumer products. Okay, like I said, for cell phones, TVs, cameras, GPS systems, everything like that. And they wanted to stay competitive and be able to make more money, so they had to figure out how to bring their costs down. Okay, so the daily water bill at IBM Burlington, including their energy and chemicals, is $10,959. So every day they're spending almost $11,000 just on water. They said most of the water used each day, 2.2 million gallons, becomes ultra pure water. And that's the most expensive kind. Okay, of that $10,000 or almost $11,000 bill, $9,300 a day goes into making that ultra pure water. And they said that's not the biggest target. That's the big target for the staff. Not much point in worrying about how much water the toilets use when 85% is used on the ultra pure water. So what they learned is that it's not necessarily about saving water, because they knew they still needed to use that same amount of water. They just wanted to be more efficient in what they're using the water for, not just using it for one single thing. Okay, so what they started to do, scroll on a little bit. They started to think about like the water cycle. So when the water starts out, it comes in from Lake Champlain, which is nearby, and they are taking that water in, and it's cold, and they had to warm it up before they can turn it into ultra pure water. So they were, when this all started, they were originally taking in this cold water, then they were spending money on heating the water so then they can use it to make it ultra pure. And meanwhile, the factory has 13 massive 2-story tall chillers using huge quantities of electricity to produce cold water even in winter. So in one place, they're already drawing cold water in, and then they're paying to heat it. And then in other areas, they were taking that water and they were using energy to make it cold. So they figured out, like, we are wasting money on heating and cooling this water in different spots, when if we were just a little bit more smart about how we used it and where we used it, we could save some money on that. So what they started to do, they were spending money on getting rid of the cold water, and then the other places they were having hot water and they were getting rid of it. So now they're trying to figure out, like, how do we get the heated water to the right places and the cold water to the right places without having to spend so much money on heating and cooling it? Is there a better way? Okay, so they started to look into this, and what they started to do, they use the cold air outdoors in the winter, which is in December, January, February, to make cold water during the winter instead of relying on big chillers. Okay, and then they looked at, when I'm done with this water that was heated in a different area, now I can send it over here and use it where it needs to. And then they started using the heat from some of that stuff to actually heat their buildings. So instead of reducing the amount of water that they still had to use that same amount. They just got more use out of the water. They weren't using it just for making the ultra pure water. They were recycling it throughout the building to help them reduce their energy costs. And as a result of thinking about this in a different way, they cut their water usage by 29%, which saved the factory $740,000 a year. But because they were able to use that water more efficiently, and because they were able to use less energy, now they saved an additional $600,000 in chemical and filtration costs and $2.3 million in electricity and energy costs. So they found that for every dollar that they could cut from the water bill, so by using that water a little bit more efficiently, they were actually saving $4 in other places. So basically, they're saving $5 just by every time they use a gallon of a little bit of water a little bit more efficiently. Okay, so the lesson that we want to get out of this, and what Charles Fishman is trying to say, is that, if we can get companies to realize that if they're more efficient in the things that they do and it's going to save them money, then they're going to start to more companies are going to start to follow suit and do that, which is going to be beneficial for all of us, because it means they're going to be wasting less water, hopefully not polluting as much water, And then there's going to be that, that 1% that we keep talking about. We only have 1% of the fresh water on the planet to use. We want to make sure that we are maximizing its use and that we are not just, constantly wasting it. So like we want to make sure that we're being as efficient as we can. So that's what IBM started to do. And it's kind of starting off a trend that more and more companies are starting to look into this because they're looking at the results that IBM had. The fact that they were able to save $1 by being more energy efficient with their water. And then for every dollar that they saved by doing that, they were able to save 4 additional dollars in energy and production costs. So that's proving, for big companies, that means like the less money I spend on that kind of stuff, the more money I can make in profit. That's what they all want to do. So when they start seeing that it's good for business, they'll start making that change.